Hi everyone, today we are going to talk about rate of change and slope of the line. Section, we will determine how quickly the responsive variable changes the explanatory variable increases. Calculating rate of change. Okay, so we're going to start off by rate of change. That's just basic. Temperature increases steadily by 6 degrees Fahrenheit in past 3 hours. What is the temperature change by the hour? And usually we take it down to as basic or simplified as possible. We find the unit ratio. And unit ratio usually means the bottom has to be 1. So to write that, you just write it in fraction because they want temperature changes by the hour. So temperature will be going on top 6 degrees Fahrenheit over 3 hours. Notice I put down all my units and they want unit ratio. That means I need to reduce it and that become 2 degrees Fahrenheit over 1 hour. And that is unit rate because that's 1 hour in the denominator. So the temperature changes by the hour would be 2 degrees per hour. That's what we say. 2 degrees per hour. And we have some other examples for rate of change. For example, in the little bullets, there's 3 other examples. The number of friends on a student's Facebook account increased by 10 friends per month. So that's 10 friends per month. That's your unit rate right there. And then the next one, the revenue of the company decreased by 3 million per year. There's your unit rate. 3 million per year. That's going to be actually a negative number. And then the college charges $70 per unit. That's your unit rate. So in this case, if you're going to write that, for example, let's do a negative one. It's going to be $3 million per year. Okay, so you can write it in words and you can write it in fraction. And the biggest thing is the per in the middle of the 2 units. And next thing we're going to do is find the rates of change. The formula for the rate of change is as follow. I did not have you guys write the big words down, but some of the words they can say it to you is, suppose that the quality y changes steadily from y1 to y2. As the quality x changes steadily from x1 to x2, then the range change of y with respect to x is the ratio of changing in y to changing in x. So pretty much you guys seen this before, maybe in even physics class. They will have changing in y over changing in x. Okay, and then just you can do that in your head in this case, or you can write it out. So example number 1 tells you just going to do that. An airplane altitude increased steadily by 10,000 feet over a 5-minute period. Find the rate of change. Altitude, this is the very important part. Altitude respect to time. So therefore altitude is going to go on top. So rate of change is just 10,000 feet over 5-minute period. That's rate of change. Now don't forget to reduce them. And that should give you 2,000 feet per 1 minute. So make sure you understand how to put all those three pieces together when it's come down to quizzes and tests, because I can ask in any of those forms. The next example is a little bit different. The first example just gave you the number. The second example need you to extract what's the difference. So let's read number 2. The temperature increases steadily from 60 degrees at 6 a.m. to 72 degrees at 10 a.m. Find the rate of change of the temperature respect to time. So in this case, you have to again understand the temperature goes first, which is in the numerator, respect to time, which is going to be in the denominator. So this is more like a hand slope already. So temperature is going to be, I'm going to do 60 degrees temperature, and then don't forget the formula says change. In y over change in x. So what I'm going to do is I'm going to say 60 degrees Fahrenheit went up to 72 degrees. Then I'm going to Fahrenheit, and I'm going to do 6 a.m. and minus the 10 a.m. So in this case, you have negative 12 degree Fahrenheit over negative 4 hours. And that is going to give you positive 3 degrees per hour. Okay, and when you do that, you should be able to write it in words, which is going to be 3 degree Fahrenheit per hour. Answer for number 2, 3 degrees per hour. So the formula for the rate of change is the same kind of things now. Suppose that quality y changes steadily from y1 to y2 as qualities x changes steadily from x1 to x2. Then the rate of the change of y with respect to x is the ratio of the change in y to the change in x. Now, based on the formula, based on the example we had before, we can say change in y is the first minus second, or second minus first. So it's going to be y2 minus y1. The change in x is x2 minus x1. Now, you can also have this switched, and then as long as you switch it the same time, both x and y, it doesn't make any difference. So you can definitely have the y2 minus y1 become y1 minus y2, but then you also have to change x2 minus x1 switch into x1 minus x2. So the direction has to be exactly the same. Now for example number 2, some people sometimes will actually write that as an order pair so you can see a little bit better. Okay, so but read the question to see which one should come first as x, which one should come second as y. So example number 2. Number 1, the number of postal employee declined approximately steadily from 583,908 employees in 2010 to 491,017 employees in 2013. The sources from U.S. Postal Service. Find the approximation rate of change the number of postal employee. So that's probably per year, rate of change per year. So in this case, you can actually say per year, that means the year is going to be the X. So my order pair is going to be 2010, comma, 5A3908. That's first order pair. Then the year for second one is going to 2013, comma, 491017. And there's your order pair, so you can find literally using the formula above it and find the rate of change. So I'm going to do, why don't you guys pause and plug in the formula and check did you get the same answer as I do. For example number 2, this is the things that they expect you guys to understand. Changing in number of employees over changing in time. Okay, and then that is going to be rate of change. That's equal to the that's equal to 491,017 employees minus 583,908 employees. And since we are doing 491 first, we're going to take the year 2013 minus the 2010. And the difference between them is it went down, or the force has shrunk by 92,891 employees per year. Example number 2. So why don't you guys give it a try, pause it, and then come back and check the answers. For example number 2, the total cost of 12 karate classes and the enrollment fee is $158. The total cost of 20 karate classes, the same enrollment fee is $230. The change per class is the same. The charge per class is the same regardless of the number of classes which you pay. Find the rate of change of the total cost with respect to the number of class. Again, they tells you what they want first. The total cost respect of the number of class. So the total cost should be on top, which is dollar amount. And then turn out to be $9 per class. And you also should understand if I give you $9 per class. Okay? Or you can write it in fraction forms. We're going to talk about is a connection between constant rate of change and exact linear association. So example 3 says, suppose that a student travels 50 miles per hour on a road trip. Let D be the distance that the student can travel in T hours. First of all, we're going to identify what is the explanatory variables and identify the responsive variable. Pause the video. You should be able to do that right now. Exemplatory variable, that's X, and it is T determine how much is the time, determine how much is the D, which is distance. So if you drive for an hour, it's going to be 50 miles. If you drive for 2 hours, it's going to be 100 miles. So that's why T is X and D is Y. We are going to construct number 2, construct a table that to describe the association between T and D for driving times of 0, 1, 2, 3, 4, 5 hours. And you should be able to come up with a calculation because every hour is 50 miles. Pause the video, set up the table, and construct the table. Number 2, sorry to give you guys a run chart, but it should be a table like this. At 0 hours is 0, 1 hours is 50, and so forth. So there's your table. Okay, and then for the next one, for number 3, what we're going to do is we are going to construct a scatter plot. Now you can just plot this by hand. You don't have to put it in the calculator. So what I'm gonna do is I'm gonna do it by hand. I have 1, 2, 3, 4, 5, and that is the 5 hours. And that is the hours on the bottom. And then to the side. So pause your video, and as you're looking at the graph, that's the scatter plot. And if you connect them, it's actually exactly a line. Okay, so in this case, what we are going to talk about is number 4. Describe the 4 character of the association and compute and interpret R as part of your analysis. If there's association, draw an appropriate model in the scatter plot. Okay, so the appropriate if there's an association, draw appropriate model in the scatter plot. And the scatter plot is, the model is exactly that line, because it's exactly that line that without any points bouncing anywhere, that's a model. Sometimes the model is not exactly the line, but since this is exactly on the line, that means if you think about it from before, it just says R equals 1. That's all. We don't need to figure out R. We just have to know, because all the points is on the line, it's exactly as the correlation is 1. And then there's no outlier because everybody bobs up, right? Everybody's on the line. The association is exactly linear. It's going because it is line, and it's positive. So that's your 4th thing you have to tell me. Okay, no outlier, unusual, and the linear form, positive, directions, correlation, 1, and then it's very strong. It's the exact line. Okay, going on to the next thing. Next thing is a summary of what we just did. Constant rate of change implies exact linear association. Constant rate change, 50 miles per hour, 50 miles per hour, 50 miles per hour, exact linear. So that's going to give you the line. Okay, that means the correlation is going to be 1. If the rate of change of one variable with respect to another variable is constant, means the same, then there is exact linear association between the variable. We just had an example on that. Explanatory variable is T for time, how many hours you work, and the responsive variable is going to be to pay the dollar, how much money you're going to get. So the next thing we are going to do is trying to find the rate of change in between and see, do I get a linear association, which is the rate should stay constant. Let's look at the chart. So if you look at the chart, the number goes up by 1 every time. And right here, the pay goes up by $10 every time, every hour. So in this case, it's $10 per hour. Okay, now since it's linear, you know it's constant. I'm sorry, since it is constant all the time, so the association is going to be linear and should be a line. So right here, this number 2, it says describe the 4 characteristics of the association. Associating exact linear, and positive, no outlier. And if you want to, you can say correlation is 1. Any question? Linear is the form, positive is direction, unusual, correlation. There's your 4 things. Okay? I don't want you to worry about punching the calculator, find out what's correlation yet. It just had to be identified. We're going to talk about how to deal with correlation a little bit later down the line. Going on to the next thing. Now graph the table above. I'm going to graph it and label it, and you guys can pause the video and do it on your own speed. So there's the graph I have. I put down the points, scatter plots, and I draw the lines and matched up. It's exactly on the line. So just proving what we said before, the correlation is 1. Now, it says number 3, find the rates of change of pay from 3 to 4 hours. So in this case, you know it's going to be changing in pays over the changing in time. So I want you guys to go ahead, pause the video, and just write it down and double check, because it's so much faster when you write it instead of just trying to sit there and copy it from me. As you finish both problems, you notice they are exactly the same, $10 per hour. So here is the next thing we're summarizing. An exact linear association implies constant rate of change. So linear means a straight line gives you the same rate. Okay, that's number 3 and 4 for the workout. If there is an exact linear association, means a line between 2 variables, between hours and pay above, if you look at the chart, then the rate of the change, which is the number $10 per hour, of one variable with respect to the other is constant, means exactly the same, $10 per hour. I hope you guys understand the wording when you do a problem. Hopefully that will help to be able to read the math book a little bit easier as you go on to college. Use rise and run to compare rate of change. Okay, the amount of money a student is paid are shown as a various number of hours worked. Rate of change is rise over run, for example, $10 per hour. Okay, you can write it like that from the previous problem. So example number 5, 1. A carat is a unit of weight for a precious stone and pearls, I think, pearls. Okay. The scatter plot and the model to the right describe the association between the weight in carats of some diamonds in their value in the Singapore dollars. So is the association positive, negative, or neither? Please pause that and then answer some questions that you think you answer question number 1. And number 2 says estimate the rate of change of value with respect to the number of carat. And the way we're going to do is, we are going to do it related to the points they give you. And if you've seen it, that should be just 14 rise. Okay, so in this case, rise is rise over run. That's what we have before as formula. And then they give it to you. Well, the rise is going up, so that's going to be $930 over the run. The run is going to be 0.9 0.25 carat. And now we are going to make sure we can simplify and reduce. And so in this case, that's just going to be if you reduce this, punch in the calculator, and that will be divided by 1. That's going to come out to be $3,720 per carat. And another way you can do it is also by doing it by slope. So which is going to be this y minus that, and then this x minus that. So you can do 1040 minus 110 over 0.35 carat minus 0.10 carat. And that's going to give you $930 over 0.25 carat. And then the rest of is going to be $3,720 per carat. So it depends on the information I give you. You need to be able to do both. Okay, going on the next thing. You guys try example number 2. So this is example number 2. You know the line is going downwards, so therefore it's negative. The rate of change in number large ships lost, that means by time. So it's 85 ships minus 164 ships. And the year is 84 is matching up with year 2014. And 164 match up to year 2006. So it's negative 79 ships per 8 years. So approximately lost about 9.9 ship per year. Okay, and then so in this case, the summary of different things says that connection between the direction of association and rate of change. This is very important, the connection. Okay, and then in association between two variables, if it's positive, then the rate of change of one variable respect to the other one is positive. Okay, that means the lines goes up this way, both positive. Okay, then associate between two variables is negative, then the approximation of rate of change respect to the other is going to be negative. So it's going to be this way, which is the shift problem. Then the next one says that if nonlinear of a rate of change of a response variable with respect to the explanatory variable is not constant. Now think about this. Before we have going up and down by the same number, $10, $10, $10. We have 50 miles, 50 miles, 50 miles. And then we have lost a negative 9.9 ship, 9.9 ship. But what if we have something that's not constant? That means those number changes. So you will get a graph look like this. And then that's a slope of a line that we have to talk about. So in this case, we are going to say, hey, this slope is 6, this slope is 12, this slope is 4. So slope of a line is going to be y2 minus y1 over x2 minus x1. And this is when we come in and say, okay, We can estimate some of it, but if the slope changes all the time, you are not going to get a linear line, a straight line. So slope changes, your line is not going to be straight. And here's the proof of that. The next thing we're going to talk about is different types of slope. And a lot of you guys know this from last year, which is great. So I just want to jog your memory. So increasing line has a positive slope. So the line goes this way. A decreasing line have a negative slope. It goes this way. This is positive. That's negative. A undefined line slope is the line goes up and down. So now if you just, when you work out your problem like 3 over 0, that's not good enough anymore for me. I want you to be able to simplify and say this is undefined. And then next one, if you have a 0 slope, it's this way. And the 0 goes on top, the number goes on the bottom. And again, that's not good enough anymore. I want you to be able to tell me that's a 0 slope. Do not leave it in fraction because that's not done simplifying. So jogging your memory, I will want you to find the slope of the line. Here's the equation. Y2 minus y1 over x2 minus x1. And you'll have the order pair x1, comma, y1 and x2, comma, y2. And then figure out, using the slope formula, find the slope of the line passing through two given points. State whether the line is increasing, decreasing, horizontal, vertical. And for AB, which line is greater slope? Which one is steeper? So now going back to here, we should add in a couple things also on the notes, which is going to be, this is going to be horizontal. And this is going to be vertical. Okay. So please stop your video and try to do the problems and then see, do you come up with the same answers I do? So this is what I have here. The question are very basically easy because I found the slope for each individual and characterized because the negative sign is a negative slope, positive sign is a positive slope. 0 is a horizontal line, and undefined is a vertical line. Now, the question is, for A and B, which one has greater slope? Well, for A, if you punch in the calculator, this gives you 8.9. Okay, now this one for A, that's going to be point, actually it's a negative about 0.714. Okay, now remember who has a greater slope? Well, the greater slope is going to be absolute value. So in this case, if you take an absolute value that guy, that's going to be 0.714. And between 9.9 and 0.714 is going to tell me B is steeper. Because the absolute value of a slope, and then you compare a higher number, it's going to be a steeper line. Thank you so much for watching. This concludes 7.2 notes.